lesson, I'm going to talk you through some trigonometry exam questions. I hope you find them helpful. In this first question, it says, prove the identity. So what I'm going to do is I'm going to manipulate the left-hand side of the identity so that it equals the right-hand side. So you can see on the left-hand side, we're subtracting two fractions. So just like when you usually subtract fractions, you need to find a common denominator before you can subtract them. So to do that, I need to multiply these two denominators together, or if you like, we're cross multiplying. Okay, so that's the first step, which I've written down already. I'm multiplying the first fraction by this denominator, so I'm multiplying the numerator and the denominator by 1 plus sine x. Okay, so here and here, and I'm multiplying the second fraction by the other denominator here. Okay, so I've multiplied top and bottom by 1 minus sine x. Okay, here and here. So then I've just grouped the two fractions together. Remember, once you've got the common denominator, you can then bring them together. Okay, and next I'm going to expand and simplify. So if I expand the first set of brackets, here I've got 1 multiplied by 1, which is 1. 1 multiplied by sine x, which is sine x. And another sine x multiplied by 1, which also gives sine x. So if I add sine x and sine x together, it simplifies to 2 sine x. Next, I've got sine x multiplied by sine x, which is sine squared x. Okay, and then be careful when you expand these brackets here, because there's a negative sign in front of the brackets, which is going to change the sign of everything. So what I advise you to do is to leave the negative sign here and write the answer when you expand these brackets, but leave it in brackets, okay? And then afterwards you can change the signs. So 1 multiplied by 1 is 1. 1 multiplied by negative sine x is negative sine x. And also negative sine x multiplied by 1 is negative sine x again. So negative sine x take away another sine x is negative 2 sine x. And lastly, negative sine x times negative sine x is positive sine squared x. Okay, and then I'm also going to expand the brackets underneath. So 1 times 1 is 1. 1 multiplied by negative sine x is negative sine x. Positive sine x times 1 is positive sine x. So the negative sine x and the positive sine x there are going to cancel to 0. And then I have positive sine x multiplied negative sine x, which is negative sine squared x. Okay, next I'm going to just change the sign of everything inside the brackets here. Okay, so when I do that, the positive 1 changes to a negative 1. This negative 2 sine x is going to change to a positive 2 sine x. And this positive sine squared x is going to change to a negative. Okay, and the denominator I'm just going to leave as it is for the moment. And then I'm going to look to see if I can simplify anything on the numerator. So here I have 1 take away 1, which is 0. I also have sine squared x minus sine squared x, which is 0. So I'm left with 2 sine x plus another 2 sine x, which simplifies to 4 sine x. And underneath, I'm just going to write out the denominator one more time. So now's a good idea to look at what we're actually trying to find, okay? We're trying to get 4 tan x over cos x. So when I look at what I have so far, I don't have a cos x here or a tan x, I've got sin x. So what I'm going to do is I'm going to make a substitution to rewrite this sine squared x differently. Hopefully you know the identity sine squared x plus cos squared x equals 1. So you actually get given this in the formula booklet in your exam for the Cambridge AS. Maybe you just know this one off the top of your head. I'm just going to rearrange it to make sine squared x the subject. Okay, so I'm going to subtract cos squared x on both sides so that I have 1 minus cos squared x. Because now I can replace the sine squared x with 1 minus cos squared x because they're equal to each other. Okay, so when I do that, it becomes 1 minus, and then I've got 1 minus cos squared x. And just like earlier, I've just left this in brackets because there's a negative sign here, which is going to change the sign of both of these, okay? So then if I just rewrite the denominator taking that into account, I have minus 1 and positive cos squared x, which then simplifies. Maybe you've seen it already. 1 minus 1 is 0. Okay, so now I have 4 sine x over cos squared x. We're nearly finished. Okay, so cos squared x is just the same as cos x multiplied by itself. Okay, so I can rewrite it like that. Then if we look carefully, there's something else we can do to rewrite this in a different way. There's another identity that perhaps you know already. It's also given on the formula sheet in the exam. Tan x is equal to sine x over cos x. Okay, so this is another identity that you need to know and be able to use. I can see when I look at this fraction here, I actually have sine x over cos x here, which is the same as tan x. So I can replace this sine x over cos x with tan x. So it becomes 4 tan x over cos x, okay, because that's still there, and that is what we need. In part B of the same exam question, it says, hence solve the equation. And you can see that these are the same two fractions that we subtracted in part A. And remember, we proved that they were the same as 4 tan x over cos x. Okay, so you can start by replacing those two fractions that are being subtracted by 4 tan x over cos x. And remember, this is equal to 8 tan x in the equation we're trying to solve. So this is the equation we're trying to solve. To start with, I'm going to get rid of this fraction. So I'm going to multiply everything by the denominator cos x. So when I multiply the left-hand side by cos x, this just cancels, and I'm left with 4 tan x. And on the right-hand side, if I multiply this by cos x, I have 8 tan x cos x. Next, I'm going to move all terms to the same side of the equation. So I'm going to move the 4 tan x over to the right hand side of the equal sign. So on the left hand side, I'm left with 0. And on the right hand side, I now have 8 tan x cos x minus 4 tan x. So you can see that we have some common factors on the right hand side. So I can factorize, okay? I can see that 4 is a common factor here. It's the highest common factor of 8 and 4. And tan x is also a common factor. So if I'm factorizing, I take out the common factors and I put them in front of the brackets, and then I can work out what goes inside the brackets. So here I should have 2 cos x, because these need to multiply together to take us back to here. 4 times 2 is 8, and tan x times cos x is tan x cos x. And then here I should have minus 1, because 4 tan x multiplied by negative 1 is negative 4 tan x. So now that we factorize, we can solve this equation. Remember, whenever you multiply a number by 0, the answer is always 0. So here the answer is 0, which means either this is equal to 0, so 0 times a number would give us 0, or everything inside the brackets is equal to 0, and 0 times a number would also give us 0. So we need to look at these two different scenarios. So let's start by taking 4 tan x and putting it equal to 0. Well, this just means tan x has to equal 0, because 4 times 0 is 0. So if we consider the equation tan x equal to 0, hopefully if you're familiar with the y equals tan x graph, you can just see that x has to equal 0. Okay, I've drawn the graph down here so you can just have a little look. Let me just move it up. Okay, can you see that? Okay, yes. All right, so here's the graph y equals tan x, and we're trying to solve tan x equals 0. So instead of the equation being y equals tan x, the y has now changed to a 0 in this equation we're trying to solve. So y is always 0 along the x-axis, okay? And you can see the curve y equals tan x intersects the x-axis here, okay? Oops. Okay, and the value of x at that point is 0. Okay, so that's why when we solve that equation, x is equal to 0. Notice how I've highlighted this part of the graph in red. At the beginning of the question, they gave us a range for the values of x, okay? So can you see at the top here? All our values of x, when we're finding the solutions, have to fall within this range here. Okay, so I've made sure I'm only looking at the graph that falls between 0 and a half pi. Okay, remember, pi is 180 degrees, so half of pi would be 90 degrees. Okay, so this falls within our range, so we know this has to be one of the solutions. If you want another method to find the solution here for x and you're not happy with looking at the graph, all you have to do to find x is do tan minus 1 of this number here, so 0, and when you do tan minus 1 of 0, you get 0. Okay, so that's an alternative method there to find the first solution. Just make sure your calculator's in radians, okay, for this question, as remember, the range here for the angles, it wasn't in degrees, it's in radians, okay, so do make sure you've got that set correctly to start with. Now let's consider this equation over here. Remember I said this bracket could also equal 0 when we're finding the solutions. So let's write down 2 cos x minus 1 equal to 0 and solve this equation. So I'm going to make cos x the subject. So I'm going to add 1 to the other side and then divide by 2. Okay, so that leaves me with cos x equal to a half. So we're trying to solve this equation. So just like that second method I showed you here, to work out the angle x, all you have to do is press shift on your calculator to find cos minus 1 of a half. Okay, and when you do that, you should get pi over 3, which also falls within the range they gave us at the beginning of the question, so we know this is another solution. Okay, if we look at our graph again, this time for y equals cos x. Down here, can you see? Yes, you can see that. Okay, so here's our graph y equals cos x. And remember, I just shaded the part that we're interested in red. Okay, so when the range of x lies between 0 and a half pi. Okay, so this part. We're trying to solve the equation cos x equals a half. So here, the y has changed to a half. So if you consider the graph y equals a half, so it's a horizontal line that would look like this, you can see it intersects our graph here in 2 places. But remember, we're only interested in the part shaded in red, so there's only actually one solution, okay, for this question. So we don't need to look for another solution in this question. So we finished. So when you solve that equation, in part B, the answers would be 0 and a third pi. In question 2, we have to solve this equation, and they've changed the range for theta, the angles that we have to find, into degrees. So just make sure your calculator is set to degrees for this question. So if I'm solving this equation, first I want to get rid of this fraction. So I'm going to multiply everything in the equation by the denominator cos theta. So if I times this by cos theta, I have 2 cos squared theta. If I multiply 7 by cos theta, I have 7 cos theta. And finally, if I multiply this fraction by cos theta, I'm just left with the numerator, which is negative 3. Okay, next I'm going to move all terms to one side of the equation. So I'm going to move these over to the left-hand side. So it becomes 2 cos squared theta minus 7 cos theta plus 3 equals 0. So I have to solve this quadratic equation to find cos theta. And I can either use the quadratic formula, or in this one I can actually factorize. So I'm going to pop it into double brackets. So here I've got 2 cos theta, cos theta. Okay, so when I multiply these together, it takes me back to 2 cos squared theta. And here, if you look carefully, it should be -1 and -3. Okay, remember they have to multiply together these numbers to give +3. And then when you expand the brackets, here you've got 2 cos theta multiplied by -3, which is -6 cos theta. And here you've got -1 multiplied by cos theta, which is negative cos theta. So -6 cos theta, take away another cos theta, gives -7 cos theta. Okay, so this is factorized. Okay, so be careful which order you put these numbers down. So just like before, if we look at this equation, it's equal to 0, which means either this bracket is equal to 0, so that 0 times a number gives you 0, or this bracket is equal to 0. So this would be a number times 0 would give you 0. So we have to consider these two different scenarios. So let's start with when this first bracket equals 0. So 2 cos theta minus 1 equals 0. So I'm going to solve this equation. Okay, so first I need to rearrange to make cos theta the subject. So I'm going to add 1 to the right hand side and then divide by 2, so that I have cos theta equals 1/2. Now in the calculator, to find the value of theta, all you have to do is press shift then cos to find cos minus 1 of 1/2. Okay, so when you do that with your calculator in degrees, you should find the answer is 60 degrees. Okay, so there's one solution. Okay, and we can see that it falls within the range that was given at the start, so this is looking good. Okay, now we just have to be careful that there aren't any other solutions. So to make sure there aren't any other, you need to look at the graph. So I've done a little sketch down here at the bottom for the graph y equals cos x. Okay, can you see that? I think so. All right, so here's the graph y equals cos theta, and I've just made sure to highlight in red the part that we're interested in. Okay, remember the range in this question goes from -90 degrees to 90 degrees, so just this part here. And the equation we're trying to solve is cos theta equals 1/2. Okay, so y has changed to 1/2. So if you just imagine that horizontal line here, y is equal to 1/2, you can see it intersects the curve in 2 places. This one is the one we found earlier. Okay, you can see that here the value of theta would be +60. Okay, so we have that one already. The other solution is over here, and hopefully you can see this is symmetrical. Okay, the line of symmetry is the y-axis. So the other solution is the same distance away from the y-axis, but on the other side. So it should be -60 degrees, okay, for the second solution. So when you write down the solutions to that equation, okay, just make sure you write down both of them. Okay, so we've got theta equals 60 degrees, but it could also be -60 degrees. Okay, now let's look at the second bracket, okay, when this is equal to 0. So when cos theta minus 3 equals 0. Okay, so if I rearrange to make cos theta the subject, and so add 3 to the other side, I'm left with cos theta equals 3. And this time, when you try and find out the value of theta in the calculator, so cos minus 1 of 3, you get maths error. Okay, so there is no solution. And if we look at the graph down here, you can see why. Okay, you can see down here, when you look at what happens when y is equal to 3, okay, remember here at the maximum point here, y is equal to 1. So y is equal to 3 would be up here, the horizontal line. And it doesn't intersect with our curve y equals cos theta, which is why there are no solutions. Okay, so the only solutions for this question would be 60 degrees and -60 degrees. In question 3, it says solve by factorizing, okay, this equation here. So what I'm going to do is I'm going to check the first 2 terms to see if there's a common factor. So I can see the common factor here, 3, and also cos theta. Okay, so inside the brackets, when I factorize that, I should have 2 tan theta minus 1. Okay, you should be able to see here when I expand those. Okay, it takes me back to what I started with. So if I've done this correctly, then I should be able to just leave a little gap here. And the next bracket, when I factorize the second part, should be the same as the first one. Okay, 2 tan theta minus 1. So if we look at these terms here, the common factor would be 2. Okay, positive 2. So here I've got plus 2. Okay, you should be able to see that positive 2 times 2 tan theta is 4 tan theta, and positive 2 multiplied by negative 1 is negative 2. Okay, so the last step here to factorize is just to write down the bracket that's been repeated, so 2 tan theta minus 1, and in the second bracket the parts that are left over here, so 3 cos theta plus 2. Okay, so the first step is finished. Okay, we factorized, and remember this is equal to 0. So similar to our previous questions, remember when the answer's 0 here, either this bracket is equal to 0 or this bracket is equal to 0. So let's start by looking at this one over here. So when 2 tan theta minus 1 equals 0. So if I rearrange this to make tan theta the subject, I'm going to add 1 to the right hand side and then divide by 2, so that tan theta equals a half. And then I can solve this equation to find the value of theta. So let's just look at the beginning of the question here. This time theta's in degrees, and my calculator's already in degrees from question 2, so that's fine. So to work out theta, I just have to press shift followed by tan on the calculator to find tan minus 1. And tan minus 1 of a half is equal to 26.565 and so on. And in the Cambridge AS exam, you need to round angles to 1 decimal place unless it says something specific in the question, which it doesn't here. So this one would be 26.6 degrees, okay, for the first solution. Remember, the 6 rounds this 5 up to a 6. Okay, and this falls within our range. Okay, so that's looking good. Now, to find another solution, when you're considering the graph y equals tan x, you would just add or subtract multiples of 180. So if I add 180 to this number, it's going to go outside the range, and if I subtract 180 from this answer, likewise, it's going to go outside the range. So there's only one solution if we solve this equation here, tan theta equals a half, for the range given in the question. Now let's look at the second bracket. So when 3 cos theta plus 2 is equal to 0. So again, I'm going to rearrange to make cos theta the subject. So I'm going to minus 2 and then divide by 3. So that cos theta is equal to negative 2/3. And then to find the value of theta, I need to press shift followed by cos to find cos minus 1 of negative 2/3. Okay, so when I do that, I find that theta is equal to 131.8103, and likewise we have to round to 1 decimal place, so it will just be 131.8 degrees for this solution, which falls within the range. Now let's just have a quick look at the graph y equals cos theta. And just like in the previous questions, I've highlighted the part that we're interested in. So when theta is between 0 and 180, so this part here. And if we think about the equation we're solving, so cos theta equals minus 2/3, we're interested in when y is equal to negative 2/3. Well, remember, it goes down to negative 1 on the y-axis when we look at y equals cos theta, this curve. So y equals minus 2/3 would be approximately here. Okay, so just imagine that horizontal line. And it intersects the red part of our curve in just one place. So you can expect to just have one solution, okay, which is the one we found earlier.